Today we are going to be learning regression analysis. Regression is one of the econometric models that we will try to understand how it is estimated and the interpretation that we can deduce from the estimation. What then is regression? Regression is simply studying the dependence of one variable on one or more variables. And we do this with a view to estimate or predict the population mean on the basis of a known or fixed explanatory variables or independent variables. In any regression estimation, there has to be, or there ought to be, a dependent variable and an independent variable. The dependent variable is also called the outcome variable. It's also called the outcome variable. Dependent variable is also called the outcome variable or performance variable. Performance variable. Also, the independent variable is called the explanatory variable. Explanatory variable. To estimate a regression model, there has to be a linear relationship between the dependent variable and the independent variable. In other words, the relationship between the dependent variable and the independent variable needs to have a certain movement. There is one thing that you need to understand, that despite the fact that regression deals with the measurement of one variable, the measurement of the dependence of one variable on another, it does not imply causation. A lot of people make this mistake. Regression is not causation, even though the model helps in the prediction of an outcome. So, no matter how strong or suggestive statistical relationship is, it does not establish causal connection. I repeat, no matter how strong or suggestive a statistical relationship is, it does not establish causal connection. To establish causal connection, it has to come outside of statistics. A theory must support the causal effect of one variable on another. Supposing you wanted to find the effect of increased income on consumption expenditure. So supposing you wanted to find the effect of increased income on consumption expenditure. Income would become your explanatory variable. In other words, income becomes your independent variable, whereas consumption expenditure becomes your dependent variable or your outcome variable. So income would be equal to explanatory variable, and consumption expenditure will be dependent variable, dependent variable. A lot of people have argued that increased income has a relationship with one's consumption pattern. In other words, if one realizes an increase in income, the likelihood is that the consumption expenditure or pattern would change. And there are economic theories that support this argument. But a theory is not empirical evidence. A theory has to be statistically proven. It has to be tested empirically. And the empirical verification or measurement of economic theory or law is what is referred to as econometrics. Econometrics. So, if consumption expenditure is denoted by Y and income is denoted by X, we would first now need to construct or develop a mathematical equation. A mathematical equation from which we would transform into an econometric equation in order to test the effect of increased income on consumption expenditure. So what I'm trying to say is that if we were asked to research into the effect of increased income on consumption expenditure, we would first of all be required to state the mathematical equation that illustrates the relationship between consumption expenditure and income. So mathematically, our equation would be y is a function of x. Y is a function of x. But this equation is too simplistic because it does not take into account the value of y when income is 0. This is often referred to as the intercept or the constant term. So to ensure that our equation, which is y is a function of x, includes that intercept or the constant term, we would restate our equation as y is a function of the intercept plus our income. That is mathematically, but this x does not represent the change in x or the change in income. It only represents income. So the change in income is also denoted or represented by a coefficient, which is also a b. So our equation therefore becomes y is a function of the intercept or the constant term plus income, the coefficient of income. Now, this mathematical equation assumes that the relationship between economic variables are exact. But in actual sense, in economics, the relationship between two variables are inexact. And therefore, what we seek to explain is the fact that aside income, there are other variables that are likely to contribute to change in consumption expenditure aside income. And these factors may include the person's gender, whether the person is a male or female, the person's age, the age level of the person's responsibility in terms of marital status. If the person doesn't have responsibility, it might not affect his expenditure, marital status, the person's educational background, savings culture, etc. So, to ensure that our estimation is not biased, we take account of other factors that are likely to impact on consumption expenditure. And we would have to include that in our model. So that is often referred to as the disturbance or error term. The error term. So the error term simply takes account of other factors that are likely to impact or influence on consumption expenditure aside income. So this therefore becomes our econometric equation. And this is what we call a simple regression equation because it involves two variables. We have a graph here, and we decide to plot income against expenditure. We would realize that this will be the pattern of the distribution most of the time. So assuming we have here consumption expenditure and we have income, you will realize that when you plot the graph, it will look like something like this, which is a regression line. You would often see the data point represented like this. Something like this. So, at a point where income is 0, you will still have some level of expenditure. And therefore, that is what we refer to as the intercept in our equation, where income is 0. We still have some level of consumption expenditure. You would also notice that all the data points are not lying exactly on the regression line. There are some of them that are outside the regression line, as we can see, which explains to us that relationship between two or more variables, are not inexact. So, the distance between a point that is not exactly on the regression line and that of the regression line is what we call the error term. The error term. So this is represented on our equation as the error term. So you would see that as income remains fixed, as income is at a fixed point, you see some changes in what? In the level of expenditure. You see some changes in the level of what? Expenditure. So this simply explains the regression equation. So having had this regression equation, it is important to empirically test the regression equation. This is the theoretical aspect of it,